we want to find the values of a and b that makes this piecewise function both continuous and differentiable at the number 3. Note that a and b are constants, and in some computer science application, we need to find some values that make the function work or make the program runs. So sometimes it requires us to have a smooth graph or continuous graph, and we need to determine those values. And this is an exercise on showing how to find some value using calculus. So what do we mean by continuous? Continuous means, okay, as the limit x approach 3, the function has to equals f of 3. That's what it means by continuous at the point 3. And what is differentiable? Differentiable means f prime as 3, that limit exists. Okay, so we're going to write out later. So we first find out what is the limit at f of x. Well, we have to take a look, okay, on the right hand side, that limit is just f of 3, because what is the limit as x approach 3 x squared? Well, just plug in the number 3 because you have a polynomial. So just 3 squared is just 9. Okay, which is the same as f of 3, because when x equals 3, you just plug in x squared. So you get this. That is on the right side, okay? Or for x is greater than or equal to 3. How about for x is less than or equal to 3? Well, limit as x approach 3, when it's less than or equal to 3, you just plug in the left side, ax plus b. That is the limit on the left hand side. And this limit has to equal the limit of the function, which also equal the limit of the right hand side and equal the functional value. So what does this equation tell us? Okay, what is this limit? Limit with constant, you just keep the constant. A is just A. You replace x by 3. Okay, so you get 3a plus b, or a times 3 plus b must equals 9. This is the first condition for a function to be continuous. And the second condition for it to be differentiable, now we need to look at both sides. Okay, so what it's telling you is limit as x approach 3, on the left hand side, ax plus b minus f of 3, which is just 3a plus b, divided by x minus 3. This limit must exist, which is the left hand limit. And it must equal limit as x approach 3 from the right, because the left hand limit equal the right hand limit, it implies the limit exists. And on the right hand side is x squared, okay, minus f of a is 3 squared divided by x minus 3. So we need these two things, these two limits to equal each other. Now, the bottom one is easy to evaluate, okay? You factor the top, it's a difference of quotient. What is left is x plus 3. And x plus 3, you replace x by 3 is just 6. You can evaluate this limit. Now, what about the limit on the top? It equals x approach 3, okay? What you have here, if you expand it, you have ax plus b minus 3a minus b. Okay, so ax plus b minus 3a minus b. The b and the negative b cancel. What is ax minus 3a? What do they have in common? They have a in common. So you factor out the a and you get x minus 3 left on the top. You divide it by x minus 3 and you have a cancellation. So this limit as x approaches 3 of a just equals a constant a. So the second condition, okay, the second requirement for the function to be differentiable give us the left limit must equals the right limit. So a equals 6. Well, if a equals 6, what is b? So 3 times 6 plus b must equals 9. So b must equals negative 9. So that will give us the answer. A equals 6 and b equals negative 9.